U.S. Army Corps of Engineers dams are part of our nation's landscape and are integral to communities and critical to watershed management. This infrastructure is routinely assessed to make sure these dams deliver their intended benefits while also reducing the risk to people, property, and the environment. These inspections are no small task and involve a number of ways to monitor the dam's health. Poor water pressure is a key indicator in both dam and levee projects used to establish baseline conditions prior to construction, monitor pressure changes during construction, and identify any trends of concern during long-term operations. One method for verifying design assumptions, project safety, and project performance is using a piezometer to measure water level and water pressure changes beneath the surface. Project engineers must also determine the type of piezometer they want to use to collect their data. Researchers at the U.S. Army Engineer Research and Development Center, or ERDC, in support of the Flood and Coastal Risk Management Program, are working to better inform that decision-making process by researching the use of fully grouted, vibrating wire piezometers against traditional ones. To accomplish their data collection, they worked in collaboration with the USACE Nashville District, which provided the test site, and the USACE Savannah District, which provided drilling equipment and expertise.
While there are many methods to install piezometers, the two most common are open standpipe piezometers and fully grouted piezometers. The research that we're doing out here at Cordell Hall Dam is to install fully grouted piezometers. We're comparing to open standpipes that are being installed. While there are advantages to many of the different methods, we are looking at the fully grouted piezometer method because it's typically faster and cheaper to install, and in certain situations it can respond faster than the traditional open standpipe piezometer method.
The geotechnical community has promoted fully grouted vibrating wire piezometer installations over conventional piezometers because of their ability to successfully monitor multiple zones within the same borehole. This method also requires fewer drilled holes, resulting in a reduced overall drilling cost. Plus, reduced embankment drilling increases project safety.
We're installing piezometers all the time in our projects, and they're really necessary to understand, how our projects are performing, and especially during construction and after construction, did our design meet our intent? And so if we can install them cost effectively and save money on each installation, we can install more of these and have a higher confidence in our construction and our design.
Providing key information to address concerns over the installation and performance of the fully grouted piezometer is a top priority of this research effort.
There's some lack of confidence in the fully grouted method because of a lack of understanding of how the different grout mixes respond to different soil formations. Those challenges can be addressed by installing different grout mixes in different foundation materials and understanding how those different mixes respond to the water pressures. The key differences in the grout mix designs is the water to cement to bentonite ratio. Those can be adjusted to match the surrounding foundation materials.
And so all the research being done will give us confidence in the data for certain situations and let us know if there's additional applications or grout mixes that are inappropriate. And then we can take that information and build that into our engineering manuals and our trainings and our guidance so that we can effectively use these tools. This research is tremendously beneficial to the entire Corps of Engineers because of the wide use of piezometers in the variety of our projects. We need to be sure that our installations are appropriate and that the data we're getting are trustworthy. And so this research will better define the most appropriate applications and where we need to take caution and maybe use a different method of monitoring that is more appropriate.